Hello, everybody, and welcome back to another episode in the Ambition into Action special series of the EPRI Current podcast. I'm Dan, your guest host, and today I am joined by two wonderful new guests. I have Ville Tulkki, the lead of SMR technologies at VTT Technical Research Center in Finland, and I'm also joined by Mark Feltner, the senior nuclear technology manager at Dow Chemical Company. So, if you've been listening along, you'll know that this special series of the podcast is dedicated towards ambition into action, the overarching concept behind the Global Forum for Nuclear Innovation happening in 2024. It's all about looking at how we can take ideas that we have and ideas that we want to make useful and benefit others and turn them into action that creates meaningful change for society. There were 4 grand challenges identified at the last global forum, one of them being the idea of nuclear beyond electricity, and that's what we're here to talk about today. This is a particularly interesting concept to me, as when I was in school learning about how energy is made, it always confused me that we take this wonderful form of generating heat, this fission of the uranium atom that we have, and we use it to make all sorts of vast quantities of heat. And then we go and throw 2/3 of it away, turning that heat back into electricity, which, I get. We need electricity to power our daily lives, to have video calls with people across the world, and to, run our shavers so that we can have nice trim beards. But we also need to be making more heat for processes. The majority of energy end use in society today comes in the form of some kind of industrial heat. And nuclear seems like a really interesting way to make that heat. It is a carbon-free approach that generates heat with the highest energy density of all known energy sources. So finding ways to take better advantage of that particularly unique attribute of the energy source is something that is clearly interesting and appealing to people all around the world. And that's why I've got 2 guests who are experts on this topic to learn more about what they see as the opportunities of nuclear beyond electricity. I'd like to start by asking Ville a question. So in Finland, you've had great success in deploying low-carbon electricity generation over the years. The majority of your grid is already decarbonized. So how is it that VTT came to be developing a reactor specifically for the district heating application?
Yeah, thanks for the question then. So basically, when we were starting to look into like small modular reactors, let's say almost 10 years ago, one of the first questions was that what is the actual reason we would deploy them in Finland and in like Nordic context and so on. And basically, we were like running through all these kind of like end use cases and asking questions like, where does this fit in? And like you said, in Finland, we have now with the commissioning of Olkiluoto 3 EPR, we have 40% of the electricity is in nuclear, more than 90% is clean. So renewables do the half, nuclear does the half. And we are having rather also cheap electricity. So electricity was not the thing, but the kind of 2 things stood out. One was hydrogen, another one was district heating, because district heating still relies on burning, and it's basically like rather concentrated use of heat. So we were kind of starting to look into this and initially thought that, okay, we would be potentially in Finland buying an international reactor like we have done successfully in several cases. But quite soon it became evident that if you just need 100 degrees C water, so you cannot have 2 big reactor in the district heating network, you cannot have 2 high-tech reactor, and electricity producing reactor is actually rather overkill for the application. We just need some heat. So, and international markets, there were none. So basically in the beginning, 4 or 5 years ago, we started this project of, okay, let's design our own just to see what that low temperature producing reactor would look like.
And that makes a lot of sense. And water at 100 Celsius we make in tea kettles on our stovetops. So having a 700 Celsius helium reactor might be an excessive application for that kind of a heat demand. And I suppose that compares to, Mark, where you all are at. So Dow's been running petrochemical facilities for years. primarily firing, I think, fossil fuels like natural gas to get some of the heat you need. When you had initially looked at all the options, it seems like a different determination was made than VTT. You, in fact, did potentially need something a little more advanced, a little higher temperature. Can you talk about how Dow and how you approached the process of identifying nuclear as the heat source of interest for decarbonizing these kind of facilities?
Sure. Prior to coming to Dow about a year and a half ago, I worked for in the commercial nuclear industry for over 38 years, various aspects of that industry, and it was great. And I was considering retirement, and then an opportunity came along from Dow to take those years of experience and bring those to a petrochemical company who was looking at building a nuclear SMR to provide steam and power, primarily steam, to one of our chemical sites. And so the Dow actually started down this journey in about 2020. The leadership started looking at the sustainability goals of a 15% reduction from 2020 levels by 2030, and overall, being carbon neutral by 2050. Looked at how to go about do that, discussed that at several levels, and about 2021, 2022 timeframe, started actually looking at several SMR vendors and started talking with them and having discussions with them. Dow currently has about 7 gigawatts of power that it produces. That is at over 30 sites, and combined, it's like 50 gas turbines and steam turbines and over 100 furnaces that are powered. And so it's a lot of energy that's being done. And we have over 1,000 megawatts of renewables, but unfortunately the renewables are intermittent. They just, when the wind's not blowing or the sun's not shining, they're not reliable. And our business is a 24-hour a day sustained operation. Our plants run for 10 to 12 years at a time without shutting down. So we have to have that reliability. So the company started looking in, like I said, the 2021, 2022 timeframe at nuclear, realizing that really the only carbon-free solution to generate the steam we need and to generate the power would need to be nuclear.
That makes sense. The extreme reliability and availability of nuclear has been a major benefit over the years. Obviously, it didn't start there. Back in the 1950s and 60s, we also struggled with capacity factors in the 50s and 60%, but certainly all recent reactors have been well above the 90% mark. And when you were considering the available options, you decided that you wanted to go with a developer who was already developing a technology. Can you comment a little on why you decided to go with someone who was working on their own design instead of trying to create your own or work with a lab or something else that you could have done?
We knew, doing the research that we had done, we knew we had to have a Gen 4 reactor, that the Gen 3 reactors just did not provide high enough steam temperatures to drive our processes. And so, that made that decision easy. We looked at the different sizes of reactors, different capabilities to get that redundancy that I talked about, the reliability built in. So we decided to go with X Energy, who has the high temperature gas cooled reactor. We determined that a 4-pack of those reactors will provide us the reliability that we need and the temperatures that we need as well. And so we design a lot of chemical processes, but we're not a nuclear development design company. And so, we had to go to one of the vendors who does that for a living, and we're partnering with them, and it's working very well right now.
I'm glad to hear it. Ville, your all's application seems to be almost the opposite end of the spectrum. Instead of the highest temperatures available, you're looking at almost the lowest temperatures available that we can realistically produce with fission power. Can you talk about how, after looking at the market options, VTT decided, well, nothing exists that really matches the needs we have, and what the process was like to shift from a research organization to fully designing your own reactor, which, while something many undergrads do in their nuclear engineering senior design project, is a substantial undertaking when you're doing it for the purposes of truly bringing a technology onto the market?
Yeah, so to address your first comment, that this is completely opposite of the high temperature reactor. I mean, basically, these novel reactors, they, at least to my thinking, they basically, you need to have also like the reactor to fit the application. And basically, we are now expanding the potential use of nuclear energy, but it also like creates this kind of like a wide variety of different use cases, at least like on a general level. We actually, well, I mean, we are still a research organization, but the kind of idea was that when we were doing the first reviews, many of these like subcontractors and potential end users and so on, everybody was a bit uncertain what it would look like. What would this kind of DC heating reactor look like? So basically, we started the project to have like very rough sketch, trying to look like how to do this kind of like inherent passive safety also for technologies and materials that have been already like fully developed. So, and also in Finland, it was very important that we would be using same kind of fuel than in the current breed of reactors, so that the final disposal would not pose like impossible challenges. So with these boundary conditions, it was basically like a light water reactor, and we were starting to, I mean, basically VTT has been supporting our regulator, our industry, for decades, and we have been reviewing existing nuclear power plants, doing safety analysis and so on. But of course, moving from analyzing existing designs to justifying your own design was a big jump, and this was actually framed with us also as a part of this kind of like a competence building. After people have done actually this thinking through, they will also have insights on why these kind of solutions have been made in different places. So originally this was to produce base level of information and to help with our competence building or tools development and so on. And this was basically taken stage by stage towards more concrete until last year we established this spin-off company, Steady Energy, to actually commercialize this thing. And VTT is still supporting them, but they are looking more and more into like engineering company collaboration to actually do all the nuts and bolts, because I mean we are scientists, we can do safety analysis, but for designing where the pipe goes and where the nuts and bolts go, it's better done by experts in that field than the scientists.
You took your identified need of producing district heating levels of hot water and applied your current knowledge of safety analysis of LWRs to an opportunity to build capability with truly undertaking your own reactor design, to the point where your capability basically hit its limit, which is the science, as opposed to the pipe laying, things that are not necessarily core competencies, I suppose, but you focused on what would be the most impactful things for VTT to do for you all to benefit from the activity, in addition to helping bring the product to market.
In many places, this kind of like integrated approach that like a research institute makes the basic idea, and it's been like ironed out by the commercial, I mean, engineering entities and so on, that it happens all over the world. But of course, in Finland, we have the issue that we are not having this kind of like vertically integrated thing, so we actually needed to outsource in the end this company for better, like let's say, for better chances for actually making this into a reality in some day.
Mark, Dow has plenty of internal competencies in the area of mega projects. You've been designing, building, constructing, and operating these enormous petrochemical facilities for decades. How much of the experience that you all have with that are you bringing to bear on decarbonizing those processes with, for instance, this nuclear energy project?
Yeah, so we've got a large project going on at our Fort Saskatchewan plant to decarbonize one of our crackers up there. That is not a nuclear project, by the way, but we're bringing a lot of that to bear here. Dow engineers, Dow procurement people, Dow project management, project directors, program directors are all involved with this project. Several of us have relocated up to the X Energy office area, so we can be directly involved in those processes. And we bring folks on a regular basis to the area to engage with the team. And we've really strive very hard, very diligently to put these two companies together to form one team, and it's working very well right now. So, like I said, the Dow team is bringing a lot of expertise in construction and construction development and techniques that a company like X Energy, who's brand new as a startup, may not have a lot of folks with those capabilities. And so the marriage of the two companies has been very strong.
And that's a really important area to get a perspective from someone like Dow. Construction in the nuclear field is an interesting endeavor where it comes down to the overview of different segments of construction by the regulator. What is and is not safety related? What is and is not nuclear quality? So having not an outsider's perspective, because clearly you have a lot of knowledge of the industry, but having the perspective of an organization who's constructed mega projects, but not with the same level of obligation that the nuclear regulator places on them, probably provides a lot of insights about where there can be efficiencies harvested and improvements made to the process, not just in what you can do with it at the end, but how you get there.
Yeah, absolutely. We have done a lot of that where our folks may not understand the nuclear way, and so they question, they challenge, and so we are changing, modifying the design of certain systems and buildings and things based on Dow input as to why does this have to be like this, and then we just keep working through that design to finalize that and get it ready.
And that speaks to an interesting tension that we run into. Ville, you had mentioned this earlier, but the idea is that you probably do need a unique reactor for any given application because the specific needs of an end user are going to be different. No two chemical facilities even necessarily may want identical reactors or heat supplying generation in the same way that no two district energy systems maybe will have the same capacity needs. So finding ways that we can standardize or apply design reuse where we can, but still taking some unique advantage of the fact that we could tailor a system to a given end user potentially gives you some interesting flexibility.
I think one of the major things here will be modularity. Like this is, for instance, for our DC heating reactors, we design it so that it has individual 50 megawatt thermal modules that can go several into the facility, because basically between for DC heating energy, you have between 50 to let's say 200 to 300 megawatts of need in one particular place. You might have within the grid, you might have more, but for one location, you're actually looking at maximum couple hundred of the megawatts of, and also for X Energy, it's the design is like a modular in the sense that you have like several high temperature reactor models. So I'm kind of thinking that for industrial uses, you end up somehow using like this kind of modularity instead of all the time redesigning your reactor to match the exact need.
It also gives you the added benefit of the redundancy you want. I know in a lot of district heating applications, when you're looking at installing boilers, you want N+1, N+2 redundancy on your system so that you can always keep people's houses warm in the wintertime for you all, or you can always keep the petrochemical facility running. So smaller and more numerous units definitely gives you some nice built-in redundancy as well. So for VTT, you have designed a reactor, you've spun out a company, you've spun out Steady Energy to begin the engineering and commercialization of this company. With a lot of the next steps turned over to Steady Energy to take this district heating reactor all the way to the market, what's next for VTT? What's next for you?
Of course, we have not finally designed the reactor. It's like more of a pre-conceptual design, which of course, needs to be taken into the engineering level next. For VTT, we are, of course, supporting industries both like domestically and especially also internationally. And also supporting Steady Energy and other Finnish companies keeps us somewhat busy. For instance, for me personally, basically the next thing is still keep on looking these novel ways that nuclear energy can support the hard to decarbonize energy sources. We just got last week a note that the European Commission is starting a grant preparation for the project I was preparing. It's a safety analysis of non-electric uses of nuclear energy. So kind of like looking all these kind of industrial uses, heat uses, and other uses other than producing electricity to the grid. So this is a topic I will be working quite a lot to try to foster new starts also.
And that's a fun one. So you'll be looking out, seeing where else you can take the same basic principles you applied to get to this point and applying it to other industries, helping decarbonize all over. That is a worthy goal for the next while. So Mark, as someone who spent a lot of time working with the operating nuclear fleet, you know firsthand a lot of the challenges that nuclear plants can face. Now that you're embedded in this X-Energy and Dow project, and you know what steps you all are taking and what sequence of activities you anticipate needing, how do you see the next 10 years going as we try and navigate a future with processes and regulations that maybe struggle to depart from the past for a future applying technologies that they may not be appropriate to handle?
There's lots of studies that have been done by DOE, the National Academies, others that had looked at our electrical grid. And we're going to have to do something with our electrical grid with the electrification of industries, with the prevalence of or the amount of electrical vehicles that are coming out. We're going to have a lot more desire and a lot more requirement for electrical power in the U.S. So we're going to have to look at our infrastructure, our distribution, our transmission systems. We're going to have to look at how we upgrade those. As more and more companies look to nuclear for their green power and green energy, I should say, it's going to be more and more challenging. I think projects like this one that Dow and X-Energy are in the middle of are going to help set the stage for those things going forward. And then the other thing is the regulatory environment is going to change. The inherent safety of these advanced reactors is widely, recognized. And to take full advantage of all the safety features and all the safety functions. I mean, the X-Energy design has fewer than 20% of the safety systems from a conventional light water reactor, and those are all passive systems. So we need to take those into consideration to manage the costs and to reduce the regulations that are required. We don't want to impact safety because safety is paramount, but what we do need to do is make sure it's cost effective. One of the things I failed to mention earlier is one of the reasons Dow has chosen our Seadrift, Texas site to do this project is because we have assets there that are expiring toward the end of in the 2030s, mid 2030s. And so as those assets age, it makes sense if I'm going to do an upgrade, so to speak, that I go with nuclear. But just to go do nuclear for the sake of nuclear is not a good business decision. And I don't see any company willing to do that.
That makes sense. But building the demonstration and the upgrade into your transition planning as you start to retire assets out does give you a convenient pathway if you think far enough out, which clearly Dow is. It's good to hear that the planning ahead starts early. But we spent a lot of time talking about nuclear beyond electricity. Sensible, given that it's the topic of the podcast. But I wanted to ask a couple of questions just at the end here about this concept of ambition into action. It obviously takes a lot, and not just one person, to be able to take someone's idea and to make it reality. And both of you are currently working on exactly that, taking the district heating reactor and taking the Dow facility and getting your ideas implemented. So for Ville, I'm curious what the process was like to well, effectively convince an entire research organization that you should start designing a nuclear reactor, which had not been in your business model historically. What was that process like? Were there any barriers you faced from people who said, well, this isn't in scope for us, we shouldn't design reactors? And what was that process like?
In the initial phase, when we identified the need and communicated it, it became like a rather popular team, and there were like lots of interested like parties that they actually like realized that this nuclear energy might be one of their like potential solutions. Quite often, it's like you have the people who are like, for instance, responsible for energy supply having different options, and they cross everything, and in the bottom there's nuclear energy, and there we were. So basically, we first communicated need, and then we just realized that there is no potential way of just buying something abroad. So next thing is that we got actually this kind of green light for the project, part because nowadays VTT's work, like one of our mission is to create solutions for the society, for betterment of the society. Another thing was that we created this beginning so that we are actually like I said, we are focusing on competence development, tools development, we're doing understanding. So as long as it's like researcher work, it's like win-win situation. Then this kind of like wheel started rolling, and of course there's always detractors, but there's also like proponents, and in the sense that with every turn we got kind of like bigger project until it was quite evident that we need to like speed this off. Whether it would have been like some other company starting to buying the thing, or the startup, it was not clear at all. But in the end, this startup route was chosen. So this is kind of like I think there has been, especially when starting this from this like first principles, it's been quite so that you need to have small steps with the like clear benefits, and then like increase the ambition. And now it's once again like let's say bigger than VTT, so it needs to be this kind of like engineering vendor solutions or research organization is there to support them, but we cannot be in the driver's seat.
So starting small, growing incrementally but sustainably, and making sure that there was a clear vision aligned with the benefit of the entire organization in the process as well as in the outcome.
When you say it's like that, it sounds like it has been very excellently planned, but more it's just been like stumbling every now and then, and basically running is just stumbling all the time and keeping yourself upright. So.
Well, as long as you're staying flexible and adaptable, I guess that's how you make the most of it and make it actually work. And to Mark, there's a lot of valuable things about nuclear. The fact that it produces carbon-free energy, the fact that it can make very high temperature heat without producing any of these emissions, the fact that it can produce extremely reliable power or energy. But there's still a lot of challenges that the industry faces. As someone who has experienced some of those challenges firsthand and is now trying to help bring this technology into a new industry for it, how are you all positioning yourselves to try and make a difference in some of those areas based on the knowledge you have without, necessarily biting off more than you can chew?
Well, the petrochemical industry has a very, very strong safety record, similar to what nuclear has as well. And so we're trying to bring the standards in safety, the standards in construction, the standards in project management, and bring all those into this industry. And it's a little bit different, right? So it's funny when I talk to people, I hear them say, oh, you're building a nuclear power plant. And I like to tell them, no, we are building a cogen unit that just happens to be powered from a nuclear reactor. Because I believe, we look at this industry and we look at this process and we go and try to nuclearize everything, and it becomes too difficult. And so the one thing that Dow's been able to do is to really limit and question, why does a nuclear standard have to be applied to this in this particular area? And so that's been the challenge, is changing paradigms. I mean, there's a lot of paradigms out there. There's paradigms within our company about what nuclear looks like and what it is. There's paradigms within the industry. I've been to several industry meetings, and people have this perspective that they have of designing and building a nuclear power plant. And in order for these advanced reactors to really take off and really help the U.S., we are going to need to change those paradigms. Some of those are regulatory paradigms as well. And the best way to change those paradigms is to execute. And so we go, with our plans going forward to execute on time, on budget, and deliver the product that we want. Those successes will build more successes. And I think that's the direction that the country can move into.
Yeah, we're at a point where clear demonstration that this is how it works and this is how it's going to work, I think, is needed. We've got plenty of smart people working on design, engineering, and licensing of the systems, but to really bring the industries who are interested and the public who wants decarbonization to happen on board, I think it's time to show up and make it happen. And I'm very appreciative that both of you are working very hard to do this for decarbonizing petrochemical facilities, district heating, and potentially many other non-electric end uses. So with that, we've pretty much come to the end of our time, possibly gone slightly over. But are there any last words that you want to leave our viewers with, maybe starting with Ville?
I think that basically, what we are now seeing is once again possibility to apply nuclear energy into new things. And I mean, we have lots of established wisdom in the previous work, but one of these pieces of wisdom is that electricity is this kind of premium, high quality product, and nuclear is only for the electricity. This is something I would like people to challenge their previous thoughts, because in the future we are going to have a lot more electricity through renewables, but a lot less heat because we cannot anymore burn stuff. So actually, this kind of heat production is something where nuclear energy will also shine.
I fully agree. The photoelectric effect and the turning of a turbine in the wind directly generate electricity. Fission generates neutrons, fission products, and kinetic energy. And making use of all of that embodied heat seems like a really great way to make the best use of the technologies for the applications that they're almost optimally aimed at. Mark, any last thoughts from you?
I would just challenge the other industries to really embrace and understand, I guess is the most important thing, is to understand the risks. Don't assume the risks. Understand the risks and manage those. And I think as we move forward as a society, we're going to realize that the risks from nuclear today are so much smaller than are perceived in the community. And I think it's just really critical that industry figures that out, understands that, and can really take this beautiful energy and convert it into practical applications out there for society.
What a great perspective. Thank you, Ville and Mark, for joining me today. That is the time we have. I really enjoyed talking with you both about all the pretty amazing opportunities that nuclear energy has to produce energy beyond just electricity, to help decarbonize challenging sectors and to potentially bring even more benefits. With that, I think we'll bring this episode to a close, and we will see you next time with the third of our 4 grand challenges for the Global Forum coming up. Thanks everyone for listening. Bye for now.